Okay, so last video we were looking at solving exponential equations. Okay, those are the problems where the variable was in the exponent, kind of like number 3 is a good classic one. The variable is part of the exponent. So we're learning how to get it out from the exponent, and that's what logs helped us to do, okay? All right, with logarithmic equations, we're starting with the log already in the problem, and so at some point we have to undo that. Okay, so a lot of times we'll be rewriting it in exponential form, or we can use the idea of inverses, like do an exponential on both sides. Anyway, when we do this, I want you right from the start to remember you must check them. Check these is the big idea here. Because logarithmic equations, logarithmic functions, I meant to say, they look something like this. These are the two. All right, and both of them never go to the left of the y-axis. So your domain is just 0 to infinity, just 0 to infinity. Okay, so you never can take the log of a negative number. You can't do the log of 0. We did those earlier. Remember how you had log of 0 and it was undefined? And remember how ln of negative 6, both of those were undefined. Undefined. Okay. All right, now let's look at questions 1, 2, and 3. All right, these are kind of basic looking, and what we got to do is figure out how to get the x by itself. And a lot of times on problems like this, you'll just change from the confusing log form into the more logical exponential form. And you do that by, let me blow these up just a little bit. Okay, you do that by looking at the base. So here the base was x, so that's going to be the base of my exponential. A logarithm is an exponent, okay? So I would raise that to the 3rd power, and that should equal 8 over 27. All right, so then once we did that, we don't really have exponential stuff at all anymore. Now we just have to undo the cubing. So we're going to come in and we're going to cube root both sides. Okay. So that's going to be x. Cube root of 8 over 27, we can separate into cube root of 8 over the cube root of 27. And we're kind of lucky on this because these are perfect cubes. And we wind up just with the answer being 2/3, period. And we're done. Okay. Now here, I don't see a base. There's not one written, like there it's x, down here it's 3. I can see the base of the logarithm. These two I cannot. So that means on this one, it's an understood 10. On this one, that's really 4 log base e of x equals 36. So ln is really base e. All right, so one way to do this is just to convert to the more meaningful exponential form. This is your base. This is your base. Here's the exponent, because log is an exponent. Exponent would be 2. That should equal x. X is going to be 100, and you're done. All right, now something I think you might find really helpful. It's just a slightly different way of thinking about that plays a little more on the idea of inverses. Because I don't want this to seem like you're just following a process. You're not really, trying to make sense of it. I want you to make sense of it if possible. So on the left side, what I could do is do 10 raised to the log base 10 of x equals 10 raised to the 2nd power. And see, this base matches that base. These undo each other. All you get out is the x. And then 10 to the 2nd would be 100. Do you kind of see how to think about it one of these two ways? Okay, I think it would be helpful. All right, now on this particular problem, you don't want to come in and try to convert right now to the other form because you've got this extra little 4 out in front. So you're actually going to isolate your log first. So divide by 4. And you don't need to have changed it to log base e. You could keep it ln if you want, but I just wanted you to really know. Okay, this is really ln, isn't it? But it's log base e. Because if you're going to convert to the other form, you needed to know the base, and that would be the exponent on it that would give you x. And actually, that's your exact answer. And by the way, that's humongous. It's pretty big when you work it out. It's like 8,000 and something. So that's your exact answer. And then you can do e raised to a power. That's the button above natural log. So second function, e raised to the 9th power, turns out to be 8,103.084. If I round to 3 decimal places. 0.8, I said. 4. Okay. All right. And again, when you do these, you don't have to. You can divide by the 4. You can keep it ln. You can tell yourself, oh yeah, if it's ln, I know that's log base e. So if I did e to the left, I need to do e to the right. These are perfect inverses because their bases match. And that would be your exact answer and so on, okay? So I kind of like that approach, but for some reason, a lot of textbooks don't really show it that way, but I just wanted you to be aware of it in case it made more sense. All right, now these kind of problems need to be checked. Down the road, like it's okay to have a base of a positive 2/3. The base can be that number and you'd be fine. Okay, over here we got 100 and it's okay to put 100 there because that's a positive number. And here we got like 8,000 something. So it's not 0, it's not a negative number. So it's okay to put 8,000 something there and it should work. Okay, now let's look at number 4. Number 4 only has 1 log in it, but look at 5, 6, 7. Okay, they have multiple logs in them. Okay, so on number 4, I'm going to do pretty much what I did on the first 3. Only let's go ahead and use that idea I think would really help you. You could do 3 to the left side as long as you did 3 raised to the right side. And the 3 and the log base 3 undo each other, and you get x to the 3rd minus 5 equals 3. That I like this approach on this one, especially because it keeps you from just saying 1 right there. Okay. Also, if you converted from one form to the other, your base is 3, your exponent is what's on the other side of the equal sign, and that should equal x to the 3rd minus 5. So you can do it either way. This way right here I kind of like, and I think it will make sense to you if you are following along in my video. All right, now you're going to cube root. So you're going to cube the left side and the right side. And by the way, when you do cube roots and 5th roots, you don't get plus or minus out in front. You also don't get i's on those. That happens on square roots. So we're getting a 2, and what we're checking is if we put a 2 in there, that this right here is inside the domain for that function. So it has to be positive, a positive number, can't be 0. And that would be 8 minus 5, so that would be a 3 right there. Okay, so that should be fine. All right, now what's going on these next, I'm going to do one more before I stop and start again on another video. But if you look at 5, 6, 7, 8, 9, we got too many logs. They're everywhere. Do you see that? So this is where you're going to be using property 2, property 1, 2, and 1 and 2 primarily to condense these so that you only have 1 log at most on each side. So I just wanted to get you started on it, and then I'll stop the video and we'll begin again on the next one. So these are different from the others. The others only had 1 log somewhere, okay? This one has logs in multiple spots. So if you have a sum of logs, you can condense that into a product. So you can take 2x plus 1 times x there. All right, now here's a really good one. I'm going to finish this one. This one works really good because you have log understood base 10 on the left, you have log understood base 10 on the right. So you could do 10 to the left side, 10 to the right side, and these would undo each other. And you would have 2x plus 1 times the x. And over here, you'd have your x plus 8. So let's go ahead and distribute. Okay. Ooh, I see a quadratic. So I'm going to focus on it like it's a quadratic, thinking I might need to get my everything on one side equal to 0. But when I subtract the x, oh, I don't have a middle term. So I might want to just use the square root method. So let me continue. Divide by 2. Let me continue the process. At this point, I'm going to square root both sides, and I'm the one writing the square root. So I got to be sure to do both the positive and the negative square root of 4. Okay, so I get positive or negative 2, supposedly, for my answer on that one. Oh, but you know what? Positive 2 is going to be just fine. If I put a positive 2 in here, I never wind up doing the log of a negative number. But on this one, if I do a negative 2 on these, see how that's not going to work? Positive 2 was fine. If I put a negative 2 right there, I got the log of a negative number. This would be okay. This would be the log of a positive 6. But if it happens anywhere in the problem, you're going to have to rule that one out. So your two answers were that x equals 2 or negative 2 you thought, but the negative 2 didn't work because at some point you would have had to do the log of a negative. So that is your only answer, okay? All right, so let me stop that. That kind of gets you a sense of how we're going to be condensing these. And if it's addition, when you condense it, it becomes multiplication, doesn't it? Okay? All right, so let me stop this video.